Oh my gosh, I'm late. I'm so late. I mean, it's 4 minutes late. This is just unacceptable. Hi, it's me, Scott. I'm late, but I don't think anyone cares. I got a delivery, like right when it was time to stream, of some PCBs from a company that made them so fast and shipped them so fast, I can't believe it. I have a mask mark on my nose from my mask. Okay, so what are we even doing ever? Well, okay, so like last week we were doing those studies and they were looking good. And then Friday night, I went on like a deep fractal dive and I learned how fractals work. Man, fractals. Okay, first of all, we need wallpaper. That thing is cool, whatever that thing is, but let's pick some wallpaper first. And then we'll talk about fractals and how fractals are much weirder than I thought they were. I didn't really understand the mechanics of how fractals are created. I thought they were like, oh, here's an equation and you just do that equation on every pixel and then these are the results. And it's not, it's almost that, but it's weirder than that and more complicated than that. Still finding nice, picking our nice Norwegian wallpaper. Risky, don't do that. Don't make me nervous. Radially looking, Draclin, totally radial. I didn't mean to make that joke. It's a joke from Full House, but here we are. Okay, so here's the thing. Learning about fractals. Fractals, okay, well, there's like a couple of degrees of what a fractal means, right? There's the sort of strict mathematical dimension of a fractal, and then there's just like a thing that has self-similar parts that repeat forever. Like, can we just find... Well, all of these are fancier, but if you know, like this is a common thing. We'll be like, oh, this is a fractal tree. And I'm like, okay, I get this. This is fine. It's just like you do a thing and then you have like one form and then smaller self-similar forms and like this Y is our like whatever you call that shape, sort of the origin shape. And then you just repeat that and repeat it and repeat it and it gets smaller forever. And then you change parameters and get slightly different outcomes from it. And that is, I understood that. That's what I understood a fractal to be. Was like, oh yeah, you do a thing and then you do it smaller and then you do it smaller. You got a big version and then smaller versions on there. It's like that made total sense to me. But then Friday I decided to learn what fractals mean in like the true mathematic sense. Like you've probably seen the Mandelbrot set before. And the way this works is crazy. Or it's just like, it's like so not what I thought it was. It's not like 10 layers. It's like 10 layers of complexity beyond what I thought it was. Where it's sort of like, from a high level part, you look at it and you're like, oh, that's great. Well, there's this form right here. There's the big circle with a little circle and a little circle, and I see it over here, and it's little and it's little. And like, so kind of intuitively looking at this, it's still, it has those same, more or less those same properties of like, okay, you have a form and then sort of self-similar versions of that form shrinking forever, and this has the same little guy on it, and like this thing's just going to repeat off into all eternity, it seems. And when you do like zooms of the Mandelbrot set, they're gorgeous, like they're very beautiful, and I love them. And I've watched like some crazy hour-long ones on YouTube, but oh, there it is again. You just zoom in, and sooner or later you're going to keep seeing the same thing, and it gets pretty trippy and intense. But I thought I understood what was going on. I thought like, oh, there's just some equation that gives you that form, and just some recursive property of that equation makes it go forever. But that's not how it works. That's not really how it works at all. And so I'm going to try to briefly explain this, because I don't even know if I can. Yeah, here's like other versions. Yeah, the word fractal often has a different connotations for the lay public as opposed to mathematicians. Public are more likely to familiar with fractal art than the mathematical concept. The mathematical concept is difficult to define formally. Yeah, even for mathematicians, but key features can be understood with little mathematical background. Yeah, so like you see some of these things and they repeat, and you're like, yeah, I get it. But so what fractal means with this Mandelbrot set is like Let's see if I can explain this just as proof that I can understand it. Well, you should definitely watch other videos if you're interested in it. Turn my mic down just a touch. So we're pretty comfortable with the idea of an XY coordinate system, like a canvas with Cartesian coordinates. That's just how so much that we do in computer graphics is based on that. You got Y going up the screen, you got X going across the screen, and then with, you know, maybe the origin's down here in the corner, maybe the origin's in the center, sometimes the corner's in the upper left, because going back to raster screens, I guess that's where, whatever reason, wherever 0 is, either here or here or here, the idea is you have some coordinates that are relative to that point, and you can describe any point on the screen. Like I could say, like, oh, this monitor's 1920 by 1080, so the middle of it is somewhere around 960 by 540. So I don't think this dot's right in the center, but it's probably pretty close. So like right around here is 960 by 540, and or like 0 on the y-axis, or sorry, on the x-axis, and 540 on the y-axis is here. So that's, we get that. When you think of the normal real numbers, you're thinking of a one-dimensional line, not a two-dimensional plane, where you just can go back and forth. And so maybe your point is in the middle, and that's where 0 is. And then let's just like look at a number line. So yeah, you know, you got, well, there's no numbers on that number line, so I wouldn't really call that a number line so much as a line. Yeah, so you have your real numbers, and it's like, okay, 0 is here, the negative numbers go this way, the positive numbers go this way. So that's, like, I think most humans intuitively understand this. But that's not always true. There's times in history where we didn't really understand negatives, and there's times in history, because why would you? If you're inventing a number system to handle crops or whatever, you don't worry about negatives so much. Maybe you do with like ledger work. I think that's maybe what was introduced. But if you're just, you know, if you're just a early human ancestor who's figured out counting because you got fingers, you probably have this figured out. Like, these are the counting numbers. These are how many things I have. And 0 came later and negative came later. And to a certain extent, negative numbers, this is a spoiler for what we're about to talk about next, but to a certain extent, negative numbers are imaginary, because you can't really count negative things. Like, you can't count 0. You can be aware that you have the presence of, like, something isn't there, so I guess that's kind of like counting 0. But you can't say I have -1. I was about to say dollars, but you can in the bank. But I was like, I don't have -1 cell phones. I either have 1 cell phone in my hand or 0. I don't have -1 cell phones in my hand. I have 1 less than I did previously, and maybe with subtraction you start to get the idea, but they don't exist as a thing. So that's the number line. But we don't have to stop there. We can have, we got other stuff. So we have positive numbers going one way and negative numbers going another way. I don't want a better representation of this. Yeah, okay. So here was our number line before. But why do we just have to go back and forth? Why can't we go up and down? And there's another, like, world of numbers that let us do that. If you remember what I means it's the square root of -1, which intuitively it's like, well, that's not possible. You could never have the square root of -1. Because any number times itself, which means to square it, always equals a positive number. So it seems like a nonsense number. Weirdly, I mean, weirdly to me, maybe to mathematicians this isn't weird, that number's critical. Like, there's so much stuff that we do all the time that actually ends up relying on that notion of what the square root of -1 is. So calling it I wasn't just like, oh, here's a weird thing, let's call it I. It's like that. It turns out to be a critical thing. It's not like, you know, when you have a 1 with 100 zeros, it's like, oh, let's call it a Google. It's like, we just made up a name for that thing, but who cares about that thing? We're never going to use it. It's like, oh, this is actually like a fundamental idea of mathematics and a fundamental building block of mathematics. Just the way, you know, our counting numbers are, or our real numbers are, positive and negative, that I is just as important. So I feel like most people kind of drop off at I. You know, like, they understand the counting numbers intuitively, of course, because they're on your fingers. They get 0 because our world depends on it, even though there was a time humans didn't get 0. And they understand negative numbers, even though there was a time when humans didn't get negative numbers. But once you throw in I, it's dumb. Yeah, I've heard this complaint before that imaginary is a bad name for it, and it kind of is. Like imaginary implies that there's something like invalid about it. Like, oh, it's just your imagination. It's creative. It's fun. Whatever. It's just a funny name, but it's not. It's just as real as the real numbers, and it's just as important as the negative numbers. And it's not that much weirder than the negative numbers. Like -2 is just a made-up concept to balance out this direction of the line. So like, I think once you come to terms with the fact that everything from here this way is kind of made up, 0 to negative, it doesn't take much to understand what's going on here. So what this dimension is just, these are the imaginary numbers, imaginary positive numbers, imaginary negative numbers. And again, imaginary is a terrible name, but all it means is it's whatever the integer is that we're already dealing with, but it's times I. So 0 is still 0 because 0 times I is 0. So like that's where these two lines meet. They share that in common. And then, as you can see here, it's just zooming up 2i, 4i, 6i. I don't know how easy that is to read. I wish Windows had an easy way to zoom like Mac does. I guess you can zoom the browser, but not Windows. So yeah, so this seems fine, but still, you might look at that and be like, well, what's the point? Like, those are just made up weird numbers. And that's where I want to get back to this idea of like, it's not just some made up thing. It's not just some arbitrary idea. I ends up being like weirdly critical in so many things we do. I use I every day, basically, in computer graphics, because most of the time when I'm dealing with rotations, they're defined as quaternions. And quaternions are 4-dimensional numbers that involve imaginary numbers. So we won't even ignore that for a second, because that's even weirder. Let's just stick with 2-dimensional numbers. So what do you call this thing where it's like, okay, we talked about how we have an XY Cartesian system here, where I can say like, oh, up here is, this corner is 1920x, 1080y. We can describe this whole thing. So you can do the same thing on the complex number plane. So any point on here you can describe, and you describe that point based on its real part and its complex part. And it's usually the notation, like a point right here would be 4 plus 4i. I don't know why it's plus and not comma, but that's what complex number notation is. It's still the same as our Cartesian XY, basically, but the notation's a little different. And actually, now I say I don't know why that is. It's critical to the way the math works, I'm sure. There's a real reason for it. Like that notation is deliberate. I just don't necessarily understand why it's that way. Okay, so what does that have to do with anything? What does that have to do with anything at all? This thing. How do you find this thing? So here's what's insane about how this works. I'm trying to even think of how to, if I understand it well enough to describe it. So normally a number, when you square it, gets bigger and bigger and bigger and bigger. And that's what we call exponential growth, right? Like exponential growth, which we're dealing with because we're dealing with that with coronavirus. Linear growth goes like this. It's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and it's just going to go forever. Linear growth is just going to grow off. I wish I could get rid of that little thing there. It's not really what I want. I guess we just zoom into this a little. So linear growth is like, it's a straight line, straight arrow. Exponential growth is when you're squaring something, or it doesn't have to be squaring, it's just an exponent, but squaring is an easy one. That is just any number to the power of 2, or in other words, any number times itself. When you do that, numbers don't just grow like this in a linear way. They get exponentially bigger, meaning the gap between every subsequent number is wider than the gap before it. Like when you count 1, 2, 3, 4, 5, 6, there's always 1 between them, right? Like it's a fixed width, sort of. If we look back at this number line, the spaces between here are always the same, right? Like you would never expect that to change. That's what 1 is. 1, 2, 3, 4. With exponential growth, It's not. It's 2, and then it's 4, and then it's 8, and then it's 16, and then it's 32, and then it's 64, 128, 256, 512, 1024, 2048, 4096. Did I do that right? Yeah, I think so. So that's exponential growth, and it plots a curve like this. It gets bigger over time. So you might say that, oh, okay, any number squared is just going to get bigger forever along this curve. And that's almost true. Any number below 1 doesn't, because you're suddenly multiplying a fraction by a fraction. So it's going to die off, but it's also going to curve. So curve towards 0. This is going to curve up forever and just explode into hugeness. And this is going to kind of like crash and burn if it's below 1. And 0 to the 0th power, I think, is just 0. Any number to the 0th is 0. Any number to the 1st is itself. Any number squared is that number times itself. I think I have all that right. Definitely you can watch other videos on this that explain it better. So, what is this? This is, we go through this whole Cartesian coordinate system, this whole XY system, right? And actually we'll say 0 is here. Looking at our complex number plane. Right, so this point right here in the middle of this complex number plane is the point right here dead center in our Mandelbrot set image, right? Like this point dead center is this point dead center, right? So what we do then is we go through every pixel of the image. I mean, it's not, I think in pixels because I do computer graphics, but a mathematician would not think of it as pixels. They would just think of it as coordinates, I guess. Excuse me. So, and for every one of those pixels, I take that complex number and I square the complex number. And then I keep squaring the complex number over and over again. So this is the part that was really weird to me, is you don't just go to one coordinate and do something like you normally might if you're doing some kind of parametric equation kind of thing where it's like, oh, go here, put a dot, go here, put a dot, go here, put a dot. It's like you go to one point and you run equations over and over again, maybe 100 times. And if it is in the Mandelbrot set, like we can even look at the definition of this, that number will not spiral out of control. So like we said, you know, normally with exponential growth, numbers will just grow, get bigger, bigger, bigger. They'll just explode. They'll get so huge. If you go through these XY coordinates and take these complex numbers, which again, they look kind of funny. They look like a coordinate, not a kind of like a coordinate, not just a single number that you'd write. They look like I just have like a single example of a complex number like this. Like 2 plus 3i is a complex number. That's one number. We just don't have a symbol for it. We have symbols. You can almost think of it where it's like we have a symbol for 0 through 9. We don't have a symbol for 10, right? When you could put a Roman numeral X, but in general, in Arabic numerals, we don't have a symbol for 10. We have to put a 1 and a 0. It takes 2 symbols for us to describe 10, right? So it's not too crazy that to describe a complex number, you also need more than one symbol. In this case, we need 2 plus 3i, which would be the real number 2 and 3i. So that describes this number right here. So getting back to going around in the Mandelbrot set, if we go through we pick one of these coordinates, say for example 2 plus 3i, which would be like around here, say, for example. Really it'd be like 1 pixel here. And you take that number and you square it and you square it and you square it and you square it and square it. If it doesn't get bigger, if it instead crashes, like we would normally expect numbers under negative numbers to do, if we do that and it crashes, it's in the Mandelbrot set And so it is then black. I think I'm saying that right. Because Mandelbrot said is any number, does not diverge when iterated from, so starting from 0 and then we square it over and over again, and it does not diverge. So that is what all these black numbers are, meaning we tried 100 times to get that number to blow up and it didn't blow up. Okay, so then what are all of these other crazy colors and things? Those are places where the number does diverge, where the number does go out of control, but the coloration is based on how quickly it goes out of control. Like, because you might not know at first. Some, like, these numbers look a little weird. So like you can see a number and you're like, is that linear or is that gonna do something crazy? And you might on the first try do it and the number's just crazy and you just know it. And you're like, this number's insane. Put a color there. But if it's like, it kind of seems, oh, nope, it goes nuts. You might not know that at first. So you have to like run it, say 50 times or 60 times, 80, 90, whatever your limits are. And if it takes you more times to discover that it's gonna go crazy like that, you can colorize it differently. And the colors are kind of arbitrary. Often it would be like, I don't know, like red, like a hue red to green, or like red all the way back around to red, like a rainbow, 360 hue. This one maybe goes from like blues to yellows. I don't know exactly what the coloration is. But anyway, I've probably explained that horribly, but it blows my mind that that's how this works. And that is like I had just never, I had never heard of that kind of mathematics before, where you're just sort of like trying something over and over again, waiting for it to go crazy. I mean, I don't know how, like, how would you actually define, if you knew what you were talking about, how would you define it? Whose fractal dimension, strictly it's topological dimension. So that's how you make those. But then there's like, I'm sure someone could explain this to you, why that leads to this crazy self-similarity. Like, it's so crazy. So I want to understand more about this. Anyway, that's what I did this weekend. Friday night, stayed up way too late. Saturday morning, like figuring out how to do the math on this, eventually porting it to the GPU. Again, way reliant on work by other people. I certainly didn't just figure these things out on my own. In fact, we went back to our friend Paul Bork. What got me interested is Paul Bork has all these fractals. I don't think I made this one. I didn't make this one, but I could. So, what I said before with the Mandelbrot, it's just, you just over and over, you square it. You just square it over and over. But there's all these other fractals that can be created by adding something else, like adding some constant or doing some more complex equation. So like this looks like there's, I guess C in this case is what the original complex number was. So there's nothing new in here. It's just, you take whatever coordinate you're on. Remember, we're looping through this 100 times. You square it, you add the original coordinate divided by the coordinate you're on, and that's what gives you the next one, or the next complex number. And that's what you watch to spiral out of control. And you can make these gorgeous forms, because I've been looking at forms of like ways to make pretty radial forms. And Paul Bork has some lovely ones. There's some others that I was super into. I didn't try this one. This may not be fractals though. Like these. This one was a pain in the butt, just because this is all number on complex numbers, right? So you're squaring a complex number. Z is a complex number, so Z is like 2 plus 3i. And so is C. So when you're doing all this math, you're doing math with complex numbers. But fortunately, other people did most of the work on that, so I was able to build on other people figuring out how to actually calculate that stuff, because it is kind of a pain. There is Dan Schiffman, I should say, was the first place I went, and I watched his videos, and he at least does the math for complex numbers being squared, and he just does it, like actually calculates it. But once I was getting into like, some of these were like to the 7th, we just needed exponential, which is really just, as long as you can multiply complex numbers, you just multiply them over and over again. So it's not too crazy, but a bit out of my wheelhouse. So I think these forms are beautiful. Tried making this one. This one was interesting because I is part of the equation. Which I don't exactly know how would I do that? Like, what? I'd have to like work this out to figure out how to actually incorporate that. I mean, it's just a constant, right? It's like pi or something, but it's a weird constant. So because that's just one I, right? So that's essentially, as a complex number, you could define, I think you say, well, let's just call this a complex number that is 0 plus 1 I. So there's 0 real and 1 I. I think we could do that and get these results. So why was I doing all of this? Well, because I still am fixated on these. I'm still fixated on these diatoms, and I've been trying to come up with procedural ways to not make the forms themselves. Well, these forms, these are decorative forms created with radial symmetry, which we will be getting into more tomorrow, I think. But to create these little guys that are inside, like, excuse me, like what could I do to get these interesting organic forms in here? And I was thinking fractals might be a way to do that. So that is why I went deep on fractals. Now that I have done that, I'm not sure that that's what I want to do. I mean, so I could use the fractals. I could use the real thing. I could maybe like find some public domain microscopic images or something of these. They're so pretty. Like, this was also why we did some of the kaleidoscopic stuff we did last week, because I think this gets close to that. That's why we did the, that thing, the super formula. Starts to make forms like this, as well as that spherical harmonics. So, and we may just want to come up with other, that's cool. I don't, so the short answer is I don't know what the answer is. Like, if I do, I don't know if I want it to look like this, but if I did, then how do I want to make these forms? Fractals seemed like an interesting thing to do, but now actually don't feel exactly right. But anyway, so what does that have to do with anything? Great question. What that has to do with anything is that I spent my weekend doing fractal stuff, I guess. I guess that's what it means. No, it means we're going to start getting into radial placement, because I'm kind of like I feel like I've done some explorations of how I want to create the constituent forms, which maybe we won't use any of them. Maybe they're not going to be organic, but I at least have some work done on, okay, if we want kind of organic components of these things we're making, we have some ideas of how to do it. And we also know that even if we haven't hit it perfectly, like there's other sort of parametric, generative, algorithmic approaches we can take to maybe approximate those things, or I mean, not even approximate, to emulate them, maybe, let's say, or create something inspired by them. So this has been a little less, how do I want to say this? These have been about form in terms of, well, let's say form, like the form of an object, the form of a thing, the form of an element, whatever word you want to use to talk about form. Now we want to think of form in terms of composition. So, and maybe we'll even just say form and composition are separate things, just for the sake of having clear terminology. So if we're saying form is like, that's the shape of this thing, and it's the shape of this thing. But the way I arrange them like this in space, this, I'll put this on top of here, and I'll angle it off like this. This is my composition. So, whoa, my horoscope says, your day at a glance, you weren't free before either. A little ominous. I don't know what it means. Okay, so thinking of composition. Composition's a big topic. We could talk about all kinds of interesting things related to composition. But we're going to talk about like symmetry, which we're going to talk about more tomorrow for like our general residency stream. But we're also going to talk about radial symmetry specifically, because those diatome compositions that we love so much. Let's look at this some more. We look for diatome. Is that how you say it? Diatome? Who knows? One of the things that is so charming about these and so attractive about these is their radial symmetry. And I'm a person that just believes that humans respond strongly to symmetry in all forms. We are bilateral creatures, so we are bilaterally symmetrical. There are lots of creatures that are radially symmetrical, and there are parts of our body that are radial symmetrical, like our iris is kind of radial, has a radial symmetry to it. So, and this one, this one has bilateral. No, it doesn't. It's off a little bit. This one has bilateral symmetry along this axis and this axis, but it also has rotational symmetry. I guess if you have radial symmetry at 90 degrees, you also have bilateral symmetry. Funny, I wonder if just the backside of these isn't as interesting because, well, I guess this is right. So for radial symmetry, you probably would want this. Like the way these rotate is always rotating counterclockwise. Whereas if you're more concerned about bilateral symmetry, you would have them rotating one or the other based on one of those axes. Maybe. Looks like that doesn't really come into play for a lot of these. Okay, so how do we want to start here? We want to just build like kind of a cloner tool that knows how to clone things radially, and let's just start with that. So how do we do that? Well, we talked about Cartesian coordinates. We have x, y to describe the system. We also have polar coordinates, where you have an angle and a diameter, and you can, or a radius, and you can describe the same thing. So if we look back at our Cartesian coordinate system, like I said before, with an x and y value, we can say any number on here. Like if we want to talk about this point, we can say it's x is 4, y is 2, right? And we can talk about this point. But that's not the only way to talk about points. It's a very common way to talk about points, especially if you're drawing on pixels, because it's a big flat screen and it just works well. But we also have polar coordinates. And they may look more like this, although you can talk about the same thing. In fact, I want polar coordinates on a grid so it's a little clearer that we can actually discuss the exact same topics. Well, okay, let's just say it's like this. So that same point, this point right here, I could also talk about it if I just talk about a radius, which is 4. Well, this isn't going to be true, actually. It's 4, which right here. Once it's here, I'd have to get the... let's do a 3, 4, 5 triangle. Okay, let's do 4 and 3, and then we know this is 5. So the radius is 5 to go here. And I know that from the Pythagorean theorem. Because a 3, 4, 5 triangle, because a squared plus b squared equals c squared. So a squared is 9, b squared is 16, meaning 25. So c squared is 25, the square root of 25 is 5. So our radius here is 5. So if I know an angle to, like, if I have my radius that's 5 and I know an angle to turn it, I can find that coordinate. I think I'm explaining this poorly, but it's sort of like, yes, I could tell you to go over 1 and go up 1, but I could also tell you, look in this direction, turn to face that direction, and then walk that far to get there, right? So again, I could say, okay, walk 4 paces over and then walk 3 paces up, which is an inefficient way to get somewhere, right? Like, we all know that the shortest distance between 2 points is a straight line. So we didn't do that. We drew an L to go over to 4 and up to 3. So instead, I could say, while you're standing here, well, just turn a certain number of degrees, whatever that number of degrees is, and then once you're facing that point, I don't happen to know that angle off the top of my head. I guess I could probably figure it out from that triangle, but I don't. I guess this is 90. I should be able to calculate this. Because if we know that this angle is 90 and we walked over 4 degrees or 4 units, and then we walked up 3, we walked over 4 up 3, we know this is 90. Yeah, we walked 4 and we walked up 3. So if I said turn 36.87 degrees, if I said face this way, turn 36.87 degrees to your left, now you're facing this point, and now walk 5 units. Is just another way to talk about things. That may seem weird and it may seem more complicated, but if you're talking about drawing things around a circle, that's a way to do it. And really, so much of the stuff that we were doing on last week with the super shapes and the spherical harmonic shapes were all based on that. They were based on polar coordinates. And they were even based on polar coordinates in 3 dimensions to make a sphere, not just a circle. Hopefully I've explained all that correctly. Anyway, so point is, yes, in Unity, if I want to put something in a place, I can mess with its X, Y, Z position, and I could put something anywhere in space. Or I could say, well, I want you to kind of look a direction and then go a direction. And there's a lot of ways to do that. Like, one of them is there's a function called look at. So I could, if I said my destination was here, I could like look it that way, and then I have a normal vector pointing that way, and then I can multiply to get it. That would be one way. But that's still an angle and a radius, right? Like, however we slice it, it's an angle and a radius. We can also do it a very lazy way. And I tend to do things this lazy way, where say I have an object like this cube, and I want to do that thing where I said like, oh yeah, let's move it. Let's go 4 units over, 3 units up. So we know we can do that. In fact, let's do that with 1 cube to start with. Let's go 4 units over, 3 units up. And this cube is going to start at 0. Well, now I can say, well, what if I just rotated and then I went in that direction? So I could figure that out. I could rotate, and then I could figure out a normal vector for that, and then I could multiply. And then at the end of the day, it's going to bake down to x, y, z, but I could change the way I calculate it. But one really easy way is if I use nested game objects, I can put my second cube inside this guy. And I can say, well, I know that I want, remember my radius was 5. Pythagorean theorem told me that. So if I just go up 5 up here, and then on this main game object, rotate, what? That would be z. What did I say? 36. Well, it'd be 90. Whatever I said. 36. What did I say the numbers were? It really needs to be the opposite of this. So that's a little confusing. I'm probably making this much more confusing than it needs to be. What did I say that number was? already closed it. Okay, whatever that number was to rotate to get here, which I think is negative 90 plus 36. Is that what it was? Whatever it was, 30.6.8. Okay, negative 90 is because where my straightforward line is different in Unity, but ignore that for a second. So I've gotten my cube to the same location using a radius and a rotation as I would have just with the XYZ coordinates. And it's more complicated, but if I want to do a whole bunch of cubes and arrange them in a circle, I think this is way easier, because then I can always just keep duplicating this cube and just rotating the that's kind of weird. Why is it not showing my... I would duplicate this and then just change the rotation, and I can just do this all day and then have, you know, duplicate, 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 and make a ring around the center using those radial coordinates. So I probably explained that poorly, but that's what we're gonna play with. It's something that just knows how to clone. You give it a radius, you give it a diameter, and you give it a radius and you give it an angle. Or alternatively, instead of an angle, you give it a number of things and then just divide, you know, figure out what your angle needs to be to make whatever number of things fit in. So I'm gonna take a very brief break and I'm gonna get a drink of water, and then we're gonna make kind of a radial cloner tool, I think. And we probably wanna make it works in editor mode, so we don't have to keep hitting run, or we can just like click a button and then generate it. I think that's what we want to do. Okay, I'll be back in just a moment. Excuse me, please. Okay, I'm gonna try not to get ahead of myself on this because there's a million things I might want to do with this in terms of like chains of animation or constraints that connect things together. But let's just start with like the simplest version of this, which is I'm gonna make a script. Why does the camera seem blown out? It's because it's a little brighter outside. No, the gain got changed somehow. Why? Why would the gain change? Gain changer. Okay, that seems a little less blown out. My teeth are wider when it's blown out, so I kind of like it when it's super blown out. But, okay, so what are we doing? We are gonna. It's gonna be. I mean, all this. I'm making all this probably sound complicated, but it's so easy. It's just like. What's the right analogy here? It's like if I had a stick and I put a pencil on the end of that stick, it's like a compass, sort of. And then I just rotate the pencil and I like lift it up and lift it down and make little marks going around. It's that same principle. There's an angle, which is the angle that I'm turning the compass, and there's a radius, which is the radius that the compass is set to. So let's do something. Let's have a change the environment. And let's make a we'll call it a radial cloner. And we could certainly come up with a way to do this without that secondary game object to position these. But when it comes to wanting to animate them, like if I just want to have them like wherever they are, kind of animate in and out, I think it'll be easier to do it this way, because then you're kind of separating. You're making it where you can still just enter two numbers and have a rotation and a distance, an angle and a radius, rather than having to like continually convert back and forth from Cartesian coordinates. So this is a way to, in Unity, still work in polar coordinates, basically. Okay, so what does a radial cloner do? A radial cloner wants you to give it a game object. What is this called? The perfab. And then when we, how do I want to do this? So we do, this is a thing that is a pain in the butt every single time, and I wish Unity just had a button that did it. Because we also want an editor script. And so that's going to use Unity Editor. And we want I've done this a million times, but maybe it takes 1,000,001 times to actually remember it, because I never get it right. Yeah, so we want a custom editor. Yeah, so this is the custom editor. So this is our radial cloner editor, and it is a custom editor for the radial cloner, right? And we want to say on inspector GUI, if we wanted to have a custom button, yeah, this. Regenerate. So this will like do the thing. And I think it's like, yeah, we need something like this. So this is how we know about our radial cloner. Our radial cloner doesn't know how to regenerate yet, but it will. And then back in our radial cloner, we just want a regenerate. Okay. Certainly have problems here. Oh yeah, you're an editor also, not a mod behavior. Yes, okay. So I think we're good. Let's just start with like, regenerate. So we do have to make an editor folder for this script, as Unity says so. There's ways around that. But. So now when we click Radial Cloner, we should have a regenerate button, and when we click it, it's going to say regenerate over here. Great. And then the Radial Cloner itself I said serialized field. Why? Oh, I have to draw the default. Sure. This. We're not seeing this serialized field because I took over the inspector, so we just want to be sure to draw the default inspector. And then we'll have a field to drop in our prefab. Great. So our prefab is just going to be a sphere to start with. A tiny one. That's too tiny. Maybe it's not. Maybe it's just far away. No, it seems very small. Why does the sphere seem so small? Don't be so high. Okay, well that's fine actually. Let's just have a one unit sphere. Someone just sent me a house listing in Pittsburgh. I'll just buy this house. Seems kind of far away. Oof. Kind of far away. Very affordable though. Is it haunted? She says it's a viral Pittsburgh listing. Oh no, is it just beautiful? Whoa. It's insane. Whoa, it has like a space command deck. What is this house? I want this house. But now it's going to be... Now it's gone viral. Someone's going to buy my house. Sad. Okay, we have a 1 unit sphere. It's so dark in here. Okay, we have a slightly brighter sphere. Great. So let's just shine light right at it. How about that? And that is going to be our prefab, at least to start with. And a prefab is just, you know, it's like a reusable thing. You just make copies of it all day. So we've talked about this. So that's my prefab. I can drop it in here. The idea is when I click regenerate, I want to make a bunch of clones of this prefab and put them in the scene. So, and this is all super, super, super basic stuff. But we got to start somewhere. So we're going to just do the regenerate on the script itself instead of doing it here where we have to like talk to the serialized properties. We'll just run it here. I think that's fine. And let's, to start with, we'll just say 10, that there's 10 of them. Float angle will be 36. Float radius will equal 2, 3. And we'll say for, actually we'll say this. We'll say like count is equal to 10. And then angle will just be 360 divided by the count. And then we want to say for I equals 0, I is less than count, I plus plus. This is all so easy. This is all just the most fundamental basic stuff. But, so what we're going to do for each of these, I can't remember how to create a game object. I think it's new game object. So we might call this like the arm or the rig or the origin or whatever. But let's just say, so this will be like the origin point that we're going to use for the transforms for these individual objects. So we're going to make a new game object and we'll say origin dot. And then we will also say game object. The instance is going to be equal to instantiate the prefab. And then we want to say prefab.setParent. Transform.setParent is the origins transform. And we're going to spell this correctly. Then we're going to say, and I'm just going to say up is like where we start from. I don't know, like where do polar coordinates properly start from? It's a little easier in my brain if it's just y. Yeah, they start. And if it was 0 degrees, so we would say x. X is equal to 1. And then we'll say prefab dot transform dot position equals 3 dot right. So it's just 1 unit off to the right times the radius. So this, we ran this right now, we'd have a big old stack. Well, that didn't work at all. The parenting didn't work. Multiple things didn't work. What did I do wrong? We created a game object that was the origin. And we created an instance. Oh, I'm sorry. These should be instance. So we messed with the prefab. I shouldn't do that. Probably makes it mad at us. Okay. Did I actually save that? Nope. We just did the same thing again. And in fact, let's put the origin inside. This, so it'll be easier to clean up, to get rid of everything inside it, because we can go whoops, and I equals child count minus 1. I is greater than or equal to 0. I minus minus. I have to loop backwards because otherwise the indexes will get weird. And then transform dot get child. I And I think we have to destroy immediate. And maybe we're supposed to use the game, do the game object and not the transform. We just want to delete everything that was in there already. Okay, so we got a bunch of stuff in here. Everything's standing on top of each other. We regenerate. Oh, yeah, it's supposed to destroy the game object. Right, because we just destroyed the transform. That'd be silly. Okay. So we keep doing this and we delete them all, but we're recreating them, so it's all fine. So let's also just stick a radius up here. Create all the objects. Build new. Create new objects. Good naming. We're doing a great job. Okay, and then that is bumping it here. So the one thing that's missing, bumping it to the right, which I really don't like. For some reason in my mind, I like it to start straight up like a clock. And it doesn't really matter. I'm going to do that for now until I come into reason to not do that. So then the only thing that's missing is origin.transform.rotation should equal Turnian.angle axis, axis angle. So the axis we want to use is forward. And the angle we want to use is just angle. Pretty sure Unity wants degrees and not radians, but I guess we'll figure it out. No, this is the wrong one. Angle axis. Oh, that one did use radians. Okay. But now I kind of want to say that the order of this is wrong, and it wants the angle first. This. Definitely messed up. Oh, well, for each count, that angle is going to change per index we're on. Of course. So now, hopefully, we can just do this and regenerate. Why did I break this time? Angle times I. What did I break this time? Oh, because I added it after the fact. Interesting. Okay, well, we're just going to do this later, after we add it in. Guess that makes sense. Probably ways I could have avoided that. That don't really seem right. Oh, sure. If I did the local position, I think it would be okay. Maybe. Okay, well that was a big pain in the butt for just making some circles. But now we could do, you know, it's a little easier now to say, interesting, why is there a big gap here? Because we looped around? Shouldn't be. If we do 20, that should be 18 degrees for each one. Oh, is it an integer problem? I guess I could just do this. Okay. And we're gonna make the radius smaller. We're gonna make the radius bigger. So that's all fine. We could also like do stuff as we went through the radius. We could also do multiple radii, which is kind of what I want to get to. Where I can have like a definition for a ring, and I can do something like per ring. You know? And also if we want to animate all these things, like know about all these things in some way so we can animate them. Kind of want though to be able to just add arbitrary where I can just like add an arbitrary formula to tell something how to behave. But then I'd have to, I'm gonna think a few ways to do that, but I don't really like any of them. Maybe with scriptable objects or something. But let's start getting a little weird, maybe. How do we want to do this? We have a few ways where you could like define rings, and like rings are your fundamental building block. Well, you'd have like, you know, the prefabs and the rings, and you could say, you could make different rules for the rings and have a number of rings. That would be one way to do it. Yeah, I don't know if I like it, but let's just try it real fast. So if we had just a class ring, and rings have like a public, I mean, they would basically have this stuff. They'd have a public int count and a public radius and a public game object prefab. And then this friend, instead of these, would have a list of ring called rings. And that would give me like a list. So I can make multiple rings. I could have 3 rings with different properties in each of them. Would be one idea. I give a lot of room for them to have relationships to one another. But let's just do this. See what we think about it. So for now, they are all spheres, but of course, each ring could be a different prefab. And they could have like 8, 6, 4 for the counts, and their radiuses could be 1, 2, 3 for the radii. And then instead of knowing anything about this, we would now do a just 4. For each. I'm bouncing around languages too much, I don't remember anything. And now we would have, this would be ring.count and ring.prefab, ring.radius. Well, that's just weird. 9 of these. Our beautiful sunflower. Well, intensive to build these though. It'd be nice to like just build some thing that randomize those for us, or let us. I don't really want to have to hand author these. Kind of want to say. I want to be able to generate the rings. That'd be kind of cool. Definitely getting to the point where we're going to start wanting some more interesting primitives here. What do we want to do? Let's make some fancy polyhedra. Some Leonardo models for things. And we could have a... get mad if I do this. If I have a count of 1 and a radius of 0, will it just put 1 right in the middle? That's handy. Okay, so we have like the very basis of this. It's not very interesting. Nothing moves. It just sticks things. It just sticks things where it's told. So one thing we could do is just make a few more prefabs with just real basic stuff. Okay, so this is an interesting one. We really want to this not keep the world position or world rotation, or we do want to. Oh, not you. This. Okay, that's better. No, we only have so many So many primitives available to us here. I was wrong. I'm sorry, I'm gonna get real confused about what's what here. How could we ensure that we have negative spaces at the top and the bottom? Can we? We can't, because we always start at the top. So we'd have to like put in a way that would let us have like an initial rotation offset. So this will just be an offset that we add when we do this. We will also add this offset. So for this one, for example, we could make it 45. Okay, yeah. And then this could be a little bigger. The thing is, we're just gonna want a million of these. Like, I feel like that's what's gonna make this interesting, is if it is interesting. This might just be a bad idea. We also like switch axes as the thing that could randomly happen, which might be interesting. Or if we did, I mean, maybe in the end we do want like spherical symmetry and make weird little sphere friends. Because composing these, I mean, it's not what we want. Not our aim here. Manually composing, I mean. But I feel like we gotta get a feel for the thing we want to do with just really simple primitives before we decide. Some of these could rotate, things like that. I don't know. Like, I just don't want to be the one that decides it. So I think we need a ring generator. Maybe. Determining, like, keeping things from overlapping and stuff like that would be a real pain. Randomize the offset. Let's just try this. Let's make a I don't know. I mean, that might be, I don't know if, like, maybe that my whole approach I just don't like. You know, it could be that we need to reconsider the whole approach, but. What do you call that? Build rings. So we would want to do like rings Not clear. For now, let's just make 10 rings. Okay, and then we want to say oh, we had there's a weird shortcut for this. How do you do it? It's like this, right? Is it like this? It's commas. I mean, these numbers are all going to be randomized, but just to see if we're actually doing this properly. So we'll loop through these. And we'll add that ring. These will be unusable, but I'm just curious how ring builder works. Okay. Seems like our ring builder works. And then we could regenerate it and be broken. So let's make a list of prefabs. And we'll want, well, I don't actually think I want to do it like this. Let's make a new ring and then just set the things individually. So ring dot prefab equals math dot random, a value 0 and prefabs dot count dot count. All right. Now it's random dot range. And then ring dot count will be equal random dot range between 4 and 10. Be 13, so it'll be 12. Ring dot radius will be equal to random dot range between like 1. This one can be float. 1f and 2f plus I. We'd really probably want to keep track of what the previous radius was and add to it continuously, but do it later. Let's skip that for the moment. Okay, so now we're going to just build 10 rings, and it's going to be silly. What a break. Could you take me to the place? No? Oh, prefabs super has nothing in it. Let's give it some prefabs. Why doesn't this work? Oh, because I was trying to put it in the wrong place. Sure. Okay, now build the rings, now regenerate. Okay. Okay, so this is starting to get a little more interesting. The rules are pretty simple. Okay, let's do the total radius thing because I think that will actually help. Okay, to set the radius, we'll get a random value. We'll add it to whatever the total radius is. Kind of silly to do that addition twice, but you're a float. Okay. So let's say, that was not the button I meant to push. We want another ring count equal to 10, and that's what we'll use here. Just want to start putting crazier numbers in there. We need to start putting in like actual reasonable ranges for these things. I think it's inclusive than exclusive. Okay, so now we can pretty easily just double this. And start to get some new radial friends. Got our camera just a little more. That's weird. How did this happen? Oh yeah, that's our problem of everything starting up. Is these things like no matter what the... So we want to decide, sometimes we want an offset, basically. So let's start with just saying there's a 50% chance. So let's say that random.value, what is it called? Right? It's not random value. So if random value is greater than 5, it's 0. Otherwise, it's essentially half the angle. So sometimes we'll offset it by half of whatever our angle happens to be. And that should help with those, yeah. So one thing we might want to do though is have like a multiplier that says greater rings can have more numbers. So like some kind of count multiplier. so that the range is relatively low to start with, but then gets higher over time. Interesting. This stuff lines up sometimes. I mean, some of these are already pretty good. I sort of already want to animate them a little bit. But our primitives aren't very good. Let's just zoom out more and make more. Let's have 50 rings. Wait, is that what I want? No, it's here. Yeah, the biggest problems are really the counts. That's why I get so sparse. I mean, this is totally, okay, realizing I'm like getting off path a little bit because, well, that's kind of funny. So looking back at our diatoms, you know, the thing I was thinking of creating was this radial pattern. But then I started to make it bigger and bigger and bigger, and now we're almost back to sort of simulating the constituent parts, not creating this. But this is so reliant on having good sort of primitives, good prefabs that you're going to clone around. So we could just create some shapes, I guess. That would be an idea. What if we did this? What if we did the... What if we just started making some... sprites? I mean, we're in 2D land at the moment. How do you do it with your little tool? Polygonal sprites. So how do we do this? Sprite editor. I don't know why it wants to open over here. That's fine. Editing's disabled in play mode. I don't know why we're in play mode. So if we wanted like a 6-sided polygon, and if I wanted this to have a border, no, I want the polygon itself to have a border. Or like extruded edge, is that what this option was? Maybe you can't exactly do the thing I want. Like I want... I want a border determined by the, but I don't want a sprite order border. I want like, I want to, maybe you can't do the thing I want. Which, that would be okay to start with, I guess. Well, we just started with a triangular sprite. Did I lose all my prefabs? Was I running that whole time? I don't know. So we can't, yeah, we'd have to make a prefab from it, which is a little annoying. So say we did this and we just gave you one of these. $100. Okay. Maybe not that many. I want to be close enough to see the pieces. You know, see what the constituent parts are. Excuse me? I don't know what you're talking about on Twitch. Okay, so we can do this. Which is like, there's something to it. It's just the start of something, but there's something to it, I say. So let's make a few more shapes. Well, let's just do this. Let's just start with 4. Don't open that. Okay. I don't know what this means. Maybe I do, actually. It's not related to the image. So we'll make the quad have 4. I hit the wrong button. And we'll make the pentagon have 5. Wait. Good grief. Let's do it. Yeah. Okay. Apply. Now I have pentagon. And then these two. Oh, stop it. Make some prefabs for these, just for a little more variety. And now, so let's try that. Let's try adding a count multiplier. We'll just always round it down, I guess. So we'll say count, and we'll just say by default it's like 1 to 4. That random number times the count multiplier times I. And then we need to floor all of this, or make it an integer. So to start with, this will do nothing, because our count multiplier is broken. So every iteration, you just get times 1, so it's going to be very sparse. Oh, well, kind of. But I'm also saying that each subsequent iteration can have one more than the previous iteration. So if I said 0.5, it would scale more slowly. If I said 2, it would get, yeah, there we go. That's what we want. Okay. So weirdly, oh, our first one is times I plus 1, because we start at 0, so this is essentially saying that there's going to be none in the middle, which we don't want. So we always want something in there. Okay, this is starting to get kind of nice, right? Like even if we aren't so intense with our scale, it's like we're getting something. And it's, you know, we're starting to get into the realm of looking a little bit like a nice, like Islamic star patterns or Penrose tiling or something. But that is, we're not even close to that, because there's no tiling here. That would be kind of cool. I think we should explore that. But tiling is that is a whole nother, that's way more complicated. To actually have this like interlock and fit together, it would be a whole other conversation. Confusing myself. We also, the random variation of our distance is a little weird, but maybe that's okay. Okay, so with 16 rings, how are we feeling? So another thing we could do question is, do we want to? And the answer is maybe yes. So let's try something insane, because I want to make 1,000 rings. And that was maybe a bad idea. Okay, Unity says that was a bad idea to make 1,000 rings. Oh yeah, it was a bad idea. Yeah. That's too many rings. I shouldn't have made that many rings. That's my fault. I'm to blame for that, for sure. Well, are we going to recover from this, or are we just seriously crashed? That must be a very big number if it's this broken. Because each of those 1,000 rings, Could have up to 1,000 tiles. These are big numbers we're dealing with all of a sudden. Well, yeah, trying to draw a million sprites. Maybe draw a million particles, but a million sprites, like a million game objects is probably a no. Okay, I think we've killed Unity. That's okay. I got oh excited. Right? Yeah. I think that's okay. Everything we cared about was in code and it's saved, so let's try that again. So the next thing I want to start doing, maybe, I just want to see it really big. I just want to see it with too much. I just want to see it with too much information, basically. Okay, so we need to, it didn't save anything, but that's fine. Wasn't much to save. We want a dark gray environment because it's just how we roll. And we want our cloner I want some pickles. What grocery day was yesterday? So now I can't have pickles for a week. How could I have made such a foolish mistake? Radial cloner and our free, or free, they're also free. 2D prefabs and that's 10. So 10's fine. I mean, I'm into it. They're very simple shapes, but like, I think we're onto something here. I don't know what we're onto, but we're onto something. And also, you know, like, I will say something that doesn't feel great about this, that feels not super great, but it's okay, is that the stuff we were doing last week was so algorithmically driven. Like there were very clear algorithms that made the things we saw, and there was definitely something beautiful about that. And we are it's no longer true, but that's fine. Wow. Okay, that's even just 100 is pretty intense. Also, let's maybe not render this at such an enormous size. I don't want to be able to render at 0.5 just because I want to, Unity. I want you to be the boss of me. Okay, so pretty slow. It starts to look like a beautiful rug. Like we've made just a very attractive rug. I'm noticing some like parts that almost look asymmetrical, which doesn't really make sense to me. Like, what's going on here? How's that? I guess it is symmetrical. It just looks funny. Okay, let's not do 100. Let's do 64 because we love powers of 2. Let's do 32. I love powers of 2. Anyway, I don't know if you love powers of 2. So, whoa, that was a weird one. Interesting. It looked like it was droopy. The way sometimes the stuff lines up. Yeah, like, I mean, I guess it makes sense. Because we're not, yeah, it's weird. each ring is radially symmetrical, but the whole composition is not necessarily radially symmetrical. Oh, upside down Triforce in the middle. Okay, as far as the next thing that we do, one idea I just had, which I think is an interesting idea. Okay, got a little lost in thought. So we can have two options, or maybe we have infinity options, but we have a couple of options of what I think would be interesting to do next. One of them is to let's say 3 options. One of them is to introduce color, which I can think of like some lightweight-ish ways to do that. That would be one. One of them would be to introduce some movement, try to get some animation going. And one of them would be to try to do this all on the GPU. Or at least generate these coordinates and then send the coordinates to the GPU to render with particles. Because then we really could get crazy with the quantity. Also, we could add Z and make it like a little bit of a tunnel. So like one idea would just be like, okay, let's just add some rotation on these, but okay, how about this? Let's do this. Let's say we want to we're gonna make a new game object. We don't want to do that here. We want to do it here. Because first we want to make the ring game object. Now I feel obligated to rename this. And we want to stick we want to make the ring game object live in there. We could number these if we wanted. And then we want the so now this should hopefully give us individual rings. This should be in here. Okay. Now we have our individual rings. So because of that, we could start to do things like this and animate our individual rings. So do we want this main class to do that animation? Or do we just make rings a thing? So these would be like the rings created from that. In fact, there's we already know about all the rings. So we could just say something weird like this. And then whenever we make a ring, we can say like can I do this? Kind of doesn't feel right. Kind of feels like something's not gonna work correctly, but let's see. So I do this, that ring game object should be null on everything. Then if I regenerate, no, I get okay, I have a ring object for every one of these now. Okay, wasn't fully sure that was gonna work. This is funny. So this first one ended up, what's your problem, number one? So if count equals 1, radius should be 0. Really? Otherwise, it could be equal to whatevs. Yeah, I got one thing in the middle. Okay, so now we know about our rings. So we could, inside our ring cloner friend, have an update loop. And how do we want to do this? And we could add just like a rotation speed in here. And randomize that. I want to regenerate. I don't know. A little weird because we have some stuff that's related. You know, like this stuff is about generation and this stuff will be about animation and whatever. Okay, so for, just gonna do ring loop. So we know the ring.gameObject. Okay, so it'll be so rotate. Is this every frame? So this is vector 3.forward, and this is ring.rotation speed. Well, those were high numbers, it seems. Seems like my numbers might have been a little high. Also, that might be not the proper way to do that. Also, okay, I don't make it way slow, and it will. And maybe we need to modify the rotation speed by the radius. Yeah, like the periods get weird, or like the way these two radii align with each other. I think, I don't know if period's right. Like interval, the count going around. Sometimes they get a little clashy. Like the middles just tend to feel a little gross. Sometimes they're okay. This one's okay. I'm just trying to think of what's like our shortest path to get from this to a study. Because this one is not, we don't have like the real-time parametric quality that we've had before. Which is, it's okay. So we figure out how to work with it. Okay, well, I don't know what to do next, so let's add post-processing. That's just what we do when we don't know what to do. Whoa, what's going on? Pep talk, thanks, Jacqueline. Wait, bot, I didn't get a pep, oh yeah, bot meteors can only knows one command at a time. You can't alert and pep talk, that's too advanced. Okay, so let's add a volume. And let's make a new one of these. And let's add an override, and let's just do our stuff. And we'll go over here. Jacqueline, I'm doing okay. How are you? How's your Monday? I'm slouching in the chair a little bit. I'm getting a little tired. I don't feel like I had to, you know, I had like infinite stamina last week for some of the stuff we were working on, but I don't have the infinite stamina for this yet. I'm trying to like it. And maybe one way to like it is to make it glowy. Sometimes glowiness helps. Sometimes chromatic aberration helps. Sometimes a vignette helps. These are things that help sometimes. Sometimes a what helps? What if we just had some dimension? What if we just had some Z randomization? How do we want to do that? We could do it per step. And we could like use like a sine wave to vary that. That might look kind of cool. So let's I don't know, man. And then transform. Oh. Does that seem like a thing? Looks like math almost. So do we actually have Z depth here? We do, which is kind of cool. Because if we zoom into it now, we should get some parallax. So let's go back to making way too many. Why are you not in the middle? Oh, the camera's up one unit. That's why. I want more depth variation. What do you think of that? That's too much. Good grief. Okay. We got a lot of variation now. I don't know why, but we do. Could also have just gone in order. But maybe it's more interesting this way. It might help if our shapes were cooler. But our shapes aren't terrible. They're just a little boring. Oh, our vignette is it's a nightmare. That was ridiculous. Ridiculous. Maybe we should just never have fewer than 4 in the middle. What do we want to do with this? Got all that depth variation now. What if we actually need the, if our radius could be smaller? Let's do something. What would this look like? Probably not cool. Whoa. Well, that was definitely an accident, but kind of into it. Ooh, J value. What is J value? Okay, this should be J. Okay, now we just get a silly cone. Alternate them back and forth. Gonna be like an hourglass shape. Yeah, that was like kind of the opposite of what I meant to do. Also make two cones. That should give us way more parallax. That's better when it's random. Also do depth for individual, like, Feather Mustard, how is it going? Do I think that symmetry is, man, see how much I slid down? Do I think symmetry is innately attractive? I do. I think it is like a very fundamental aspect of the way of human perception. And I kind of think that it has to do with like just the basis of our organism, just that we're like bilaterally symmetrical creatures, but we live in a world with all kinds of radial symmetry. So yeah, I do believe that symmetry is just like a fundamental aesthetic. There's a fundamental aesthetic draw to it. Like, this thing is not very good. It's just a whole bunch of tiny things repeated over and over again. Yeah, I think it's kind of built in. I'm sure there's like studies on the psychology of that, but I think it's a little deeper than psychology. I think it's a little bit, there's some biology to it. There's just something to these forms. I would be interested to know more about why that is. But definitely my belief is that we just love it. Humans just love it. So all the different depth layers give us more parallax, which I think is good. The problem is once we're out here, it almost feels like noise. Like, this thing doesn't hold up super huge, I don't think. Because it just starts to look like concentric circles. You really lose the... I don't know, any interest at the macro level kind of falls out. I do, so, okay. So the thing I had, like, once we're right here, this bit of movement, I think is really good. Like, I really like what's happening here. Just that parallax is nice. Once we're out here, I think it's not as interesting, and the edges just look like noise. But I think there's something to it, like right in here. So that makes me think that we just want to spawn rings. Like, what if we did that? We just spawned rings with a bunch of different speeds and had them just... Sounds kind of cool, I think. We're getting further away from what our original goal was, but we have a new goal. This is a short game. I'm trying to win this battle. We'll focus on the war another time. So, okay, what that would look like is we could our little regenerate ring, this build rings thing. We could have a public ring build ring, and let's just like this whole idea of what it means to be a ring. Okay, yeah, interesting. But when the ring animates, we don't just want to scale it up. We want to scale up the radius of the constituent parts. So the way rings animate needs to be a little more complicated and a little more thoughtful than what our current implementation is. So, you know, we could start, it's almost just this. It's almost just, I think we're missing one parameter. Yeah, the total radius. Ring, ring, and then return this ring. Well, return. Falling apart over here. Okay, so, nope. This. And like, where do I get this? So this is sort of like our base radius that we're going to build on. Oh, yeah, the count multiplier is another thing. Oh, that one's kind of tricky. Well, let's leave that out here for now, because those are two things that actually... We need to remember to alter our count multiplier. What are you mad about? Is it? Okay, we need to make our rings public. So we want to, when we build a ring, we want to tell it about our total radius and okay, this feels a little gross, but it's just like we're trying to factor some stuff out to be a little more standalone so we can use it in a different way. So hopefully this just still works in the way it's supposed to. It definitely seems like I've broken it. Like, super broken it. Okay, I'm gonna remove that depth stuff for the moment because it's just confusing me. Well, that's a nice little shape. Look at that shape. That's not a bad shape. What if we just had millions of shapes like this flying at us? You do know what you're talking about. I think that's the problem. I think there's something about the scale of the relationships of these things become, yeah, the density becomes noise at the outer reaches, which is not good. Like you start to lose what makes this interesting. I think it starts to just become, well, now I've definitely broken. What have I broken? Something about the radius. But yes, in those earlier ones, yeah, it just looks like pixelated noise at the outer edge. When on the inside, when we have some parallax, I think it looks good. So I guess my aim at the moment is to sort of reconsider what we've built so far, but without damaging it so much that we like lose the initial work, which maybe I shouldn't worry about. Okay, what did I do to break this so much? This is wrong. Because we've already added total radius, like our base radius is already added inside here, which is a pretty weird one. So I could either let's do this. Let's say we just take in a radius and we take in a count. And the radius we take in is what we want. So okay, and that's going to be good. And then float count is going to be, we'll ignore this thing for now because I don't actually like the way it was working. Like, in fact, like radius is just radius. And this whole notion of the count multiplier, we'll do outside. So now we have we can just give it a radius and a count. Back to the very basics of what we had early on. This is an integer. Wait, what did I have in here? What was count before I ruined everything? Random range, yeah, it was all this. So we do still want this. Okay, so we want a random value between 1 and 4 times 1 plus whatever iteration we're on, etc., 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 etc. We want to make sure it's an integer. Here an integer. Okay. Hopefully we're back to where we started. Radius is the random range here. You doing something weird in here? Oh. We probably didn't even recompile because it's broken. Everything's broken. Okay. So, well, cool. Interesting. Really, we're doing great. Okay, now, yes, we're back at where we want to be. So yes, totally agreed. Once we get beyond a certain point, it's kind of like diminishing returns. Like when we're at this point, we can still look at it and be like, okay, there's individual shapes up here. There's interesting patterns. I think it's good. maybe even at 32, but I don't know, I'm not convinced. So we have our little like generator builder friend, and we can do this all day. Make different patterns. Okay, but I'm pretty sure I just don't like this. Count will never be less than 4. 3, 4, 3. 3 is the minimum you need for radial symmetry. If you just have 2, it's bilateral symmetry. And we really could go through and enforce that all of these are like multiples of 3 or something like that, but let's not do it. Look at like 3 and 5, whatever. And then we don't care. Well, that's still okay. We'll get to that next. Okay, doing these things, we're building at greater density, which maybe we're too dense now. I haven't seen any overlapping, which is good. Yeah, maybe we're too dense. This gets to be 3 or 4. Oh, that's interesting. But like 3 versus 4 relationship really sets it up for, because it becomes almost like an even versus odd relationship. Kind of into it. Kind of into it. What if we went 0.75? It might be better here. It almost feels too dense. Almost. Okay, but we don't actually even care about any of this, right? Because the thing we're about to do is do this in a different way. It almost looks like, oh, what's it called? Phyllotaxis. Almost looks like phyllotaxis patterns. Like these. Not quite. Like these are very, there's a specific formula to get these. Dan Schiffman has a video on it. Plug in Dan Schiffman a lot today. Okay, so funny because what I'm almost about to propose that we build is a weird particle emitter that's just going to emit these rings, emit rings of different densities, and just scale them up basically with a little bit of rotation. Let's try it. Let's just try it. So I kind of don't want to just kill this though. These aren't bad. Who could be calling me at this time? A package. Oh, okay. Well, very important. Learn you some Python. Book bundle. Thanks. Thanks, but I don't think so. Okay, so let's think about this. So we got these. Do we like this? I kind of like this. Like I kind of just don't want to not do something with this. But we'll put it on pause for the moment. We've got all the code, we can still do it, but I'm gonna just destroy our beautiful ring. I like our magical push a ring button. I think there's something to it, but just like in the interest of today, just creating a little study, we just want to make a spawner that's going to spawn rings, probably. So we want like a spawn interval. No, field. Serious field that is a float. Spawn in. And then like a private last spawn. Oh, that's also a float, by the way. So if oh, good problem. These rings also have to be 0 rings. Do what I'm thinking about that. Okay, so if time minus last spawn is greater, our spawn interval, let's start it out just every, let's just do every 1 second to start with. We did this with the coroutine, but if we did it in the coroutine, we still want to actually do the drawing in the up bit loop anyway, so might as well just sit here. So if time minus the last spawn is greater than the spawn interval, and it's not the most precise clock in the world probably, but I think it'll be fine. Then last spawn equals time.time. Ring equals new ring. Ring. Yeah, this is, okay, rings don't know how to expand. Because we don't just, I don't think. I don't know, actually. I don't know if when we scale these rings up, if we're going to try this zoom multi-layer thing, if we want the rings actually to expand, so either like they just grow uniformly and their little nodes grow as well, or if we want the nodes themselves to stay the same size and expand. It's certainly easier to just scale the whole thing up, for sure, and move it forward in Z maybe. So let's not think too hard about this to begin with. We'll make a new ring with radius. Wait. Oh no, we build ring. That's how we have to do this. Ring equals build ring. And it's going to have a radius between 1 and 1. And count is going to be let's do 3 and 5. I'm pretty sure this is inclusive, non-exclusive. Oh wait, inclusive, exclusive. So that it would be 3, 4, or 5 for those 3. So we're just going to do this every frame to start with. Right? And then, no, every 1 second we'll spawn a new thing. And then we will just do a thing where we like do ring. I don't know if I can actually do this, but let's try it. Oops. I'm in the wrong language. Okay. This might just be a mess. I mean, there'll be uniform scaling. They're just going to fly out at us. We'll see if this works at all, which I'm not totally confident that it will. Great. Spawn interval is 0, so that's not going to do much for anyone. We need to add it to the rings list also. But I didn't even see them appearing. Minus the last spawn is greater than the spawn interval. Do the thing. Last spawn is equal to time. We're going to make a ring. I'm going to add it to the list. Who knows what's wrong? Oh. There's an error. Right. Right. We're just making a ring. We're not making the ring game object. That we do here. That's funny. Of course. We just don't have the actual representation. So this is starting to get kind of messy. Like there's certainly better architectures we could have for this. Let's build the ring object. Okay. Yeah. Of course the thing that I just tried would not work. Because we didn't actually make the thing. So that happens here. Like this is the thing. And this is where we like learn all the stuff about it. Okay, I'm gonna do this in a way that's pretty silly. It'll be like ring, game object. These are bad names. Ring game object equals build ring object. And it needs to know about a ring, which is silly because we're going to be setting. In fact, let's just do ring.game game object equals. And this is going to take a ring in it. And for the most part, the code should just work, I think. Like, structurally, it's absurd. But I think it will just function. Okay, let me try it with our old generator code first. Okay, so that's happy. I like these. They're like so, they're just a little too dense. That's definitely not dense enough. Is that a 2? Am I getting all these count 2s in there? Are they count 2s? Yeah, how am I getting count 2s? Oh, because it's even on the first one. I'm doing the... Oh, that's silly. Okay, I'm going to ignore that problem for the moment because that's a silly problem. So, what are we doing? We did all this. Let's... I just want to clear all these. Clear. Clear is gonna do this thing, and it's gonna do the other thing. This thing. Just so I can throw everything away. Okay, so. So, right, when we make a ring, I guess it can be when we build it? no. Let's not. Let's keep it separate for now. Okay, this is the thing I was trying to do 10 minutes ago. Oh, for very silly. I'm not gonna call them bugs. They're just oversights. Wait, clear it all. Clear. Okay, we're making things, which is good. Their scale is 0, which is bad. This is like scaling up 1 unit per second-ish. And we can add a multiplier, like a speed multiplier in there as well. Okay. So the camera doesn't need to be 1 trillion miles away anymore. And in addition to scaling up, they should also move forward, probably. Are we doing that? I guess we are. It's not fast enough. No, we're just scaling them. So how did they end up with Z? Is depth still a thing? No, we weren't even using that. Oh, we just don't want this at all. It's just moving it 1 unit forward. That doesn't seem right, though. I'm confused. Unity's confused as well. Okay, that's everything just on 1 plane. Fine. So we want it to move forward. We really want that even more than scaling up. Or maybe we want both. So, and then we're rotating this thing. We're moving it forward. We are scaling it up. We kind of want it to come out of nothing. We may not want to scale it at all. Maybe we just want to move forward. Fast. Dirt. I don't know. This might be the wrong way to get what we want here. Well, that's literally the wrong way. Goodbye. Goodbye, my friends. Farewell. We want that up. We want to go the other way. So let's make that negative, or negative forward, I guess. And maybe we do want scaling? I don't know. I think our radius was too small. Maybe they should fade in. I kind of want the individual pieces to do a thing. Okay, that's not the worst. It's just... it all went too fast and we're too close, I think. Well, maybe let's just try bigger. I mean, further away. What if it was between 1 and 20? This is not going to look good, I think. But let's see. That looks cooler out here. Yeah, we're just too close. Everything started at scale 0. We might be getting closer. I mean, if you look over here, it's starting to look cool. How far back am I? Wow! Really far. Okay, so let's start the scale tiny. Double our count and lower our speed more? Whatever, count 16. Boss me. You can also be 16. Just powers of 2 everywhere. Power of 2. Power of 2. We'll leave 360 because it's reasonably important. Okay, sit up. We emit at a way higher rate. Also, we need to destroy the old ones, or... We'll call it their birth. Their birth. Their birth. When we build a ring... We'll call those. We'll call them later. Just loop backwards and throw them away, I guess. Okay, so... In fact, let's just do it. We have a backwards loop somewhere already, don't we? That's for the children. Contains count. For int I equals count minus 1, I is greater than, or wait, greater than or equal to 0, I minus minus, ring equals rings I. If time.time minus ring.birth is greater than 10 seconds. Oh, this is lame. We need to remove it from the collection. Is this right? Something like this. I forgot what the other thing we were going to do is. Oh, faster. Spawn interval. Well, we can change that at runtime. Oh, we didn't. So, like, almost cool. The color would help. That popping must be our death after 10 seconds, so that can be longer for now. It's an easy way to deal with it. How about 16? Getting pretty jumbly at the edges. I also kind of want the camera to rotate, or just for this whole thing to rotate. Which would be silly, because then we're like counter-rotating, because these have individual rotations. So maybe they're just too slow. Film grain, that'll make me feel better. How do you think they interact? Like the individual pieces collide or merge? What do you think? kind of the biggest problem I feel like right now is just, you know, when they block each other, when they go a little blocky. So there's a couple of options for that. One is like different coloration would help them pop against each other, for sure. We can do some kind of color over lifetime. So far we're doing everything. Oh, when they overlap, yeah. The overlap, although in reality the overlap is just kind of optical overlap because there's no real spatial overlap. So that we're thinking of the same problem because the optical overlap is I'm considering either we change colors just so they have some contrast as they pass each other. That would maybe help with the parallax filling too. And then, or these are not solid is another idea, is that our primitives are just outlines of these shapes, which would be very easy to build some of those. I was just lazy and made them solid because Unity offered that. That is the worst part, certainly, when they get real overlappy. This would be better in VR, because then you would have parallax, so things just wouldn't be as right on top of each other as they are. The individual coloration is just slightly annoying, only because I'm not... Because I'm doing this in a really raw way, you know, where I have some notion of what a ring is, but I currently don't have any notion of what the elements inside of a ring are. We could be real silly, though, when we... How do we even do this? So that's separate. That's where we take the prefab, we instantiate it. So we know about this instance, and so we know that it's got a sprite renderer on it, so we could do instance.get component sprite renderer .material .color, is it? That's gonna be great. But I don't know if I had the coloration. I mean, maybe we'll do coloration anyway. Yeah, okay. So now we can control color. And if we wanted, let's just random color utility. No. Oh no. Okay, this will just be a rainbow nightmare, I think. We could modulate the color as it went around the ring. Oh. Well, so now we have like a clown confetti party. Not what I meant to do. We need to pick the color out here. I mean, we can always do, you know, how do we want to do this? One of the nice things about this approach, we always know the angle. And so if we wanted to modulate the things as they went around in some radial way, we can, which is sine. In fact, we probably should have already done that. We probably should have made all these spin. Okay, so now we have still a ridiculous clown party, but at least we have contrast with the overlapping now. So I'm pretty sure I want it to be monochromatic. Like, we could do variations. We could do randomize the value instead. Or whatever. Do like a... Let's just try it with grayscale. That was not right at all. We need 0 saturation, not saturation 1. But this is the idea. We have value variation to give contrast. I mean, I actually sort of don't even mind the color. What if it was cyan? Oops. Let's differentiate a little. Works well with this BPM. The stacking on chop I thought would be cool, but now I don't like it. Like in like our earlier, we don't even have to do that, but that was kind of the point of what I was trying to do. Like where they get jammed up, the log jam. Maybe we have too much variation in our scale speed or in our translation speed. Because obviously we could time it where it just grew and they were radial and, you know, they went one after another and maybe that would be fine. But I thought the overlap would look cool. But maybe it doesn't look cool. So let's just see it without it. So if we do like if that speed was just a constant, I don't know what that constant is. Really should expose these things so I can edit them at runtime. But I'm not gonna. Well, for some reason I left the chat room and now I'm back at the chat room. So if you said anything in the last few minutes, I might have missed it. Sorry about that. Okay, so not quite fast enough to prevent overlap. Close. I mean, our scale speed could also scale up faster. We have this weird interplay of position and scale that is probably just making things complicated because it's on, you know, from a two-dimensional standpoint, those are doing the same thing. They're making them bigger on screen, but they're like fighting a little, and I think that actually hurt us, and we just want to make this 12, maybe. I mean, because if we're not going to do the parallax thing, there's actually zero reason to do both. Like, we could just do it with scale. So how do we make this cool? Geometric primitives, three-dimensional geometric primitives might be, I mean, because I kind of like this, it's just not, it's just like a little bit boring. It's just a little. Also, I don't like how slow it is sometimes, the rotation. So let's change the way we calculate our rotation speed. Because I don't want it to actually just be totally random in a range. I want it instead to be random in a range and then possibly positive or negative. So like, because the problem here is you could end up with zero rotation speed. So let's go between 4 and 8 and then times random dot value I don't know how you get like a random sign other than this. 0.5. Oops. Like, it's going to be between 4 and 8, and it's going to be positive or negative. There's probably a way to get random dots, like a random sign. Kind of feel like if these are all geometric primitives and they're doing their thing, and then they're scaling as part of this global thing, but then they're also rotating themselves, I think it might look cooler. But I could also be totally wrong about that. And that would help. That would justify a little bit having the scale and rotation. Okay, so let's just see what that looks like. Let's not do the color for a second because it'll break. But we have the ability to just drop in. We still have three-dimensional prefabs. They're bad, but we have them. These. Oh, shadows, huh? Interesting. Okay, it's definitely doing the thing where it's hypnotizing me a little bit, so I think that means I like it. The shadows I didn't actually mean to do. We want a little more position, a little less scale. A hard balance. I mean, it's interesting to stare at, even with these goofball shapes. I want to put in cooler shapes, but the goofball shapes are okay. I'm also realizing I don't think I have Maya installed on this computer. Do I? No, I have a file called Adobe Mayan Art.png. It looks like this. So I think this is different than Maya. Okay, so we could what could we do? We could make this not brown. Like, I kind of feel like it might be cool. Like if these were a bunch of more interesting polyhedra, and those interesting polyhedra were doing stuff. I'd really like it if I could just download that, though, instead of installing Maya. If I could just download a bunch of OBJs. Paper models of polyhedra. Polyhedra.net. It said OBJ, though, so I would have hoped that you would give me 3D models. But I just want, like, I don't want anything fancy. I want some weird academic who has a list of all the polyhedrals. Wait, not polyhedras, polyhedra. Like, just like platonic solids. Math is fun. Animated polyhedron models. It's beautiful. Oh no, Adobe Flash. Yeah, stuff like this. I want these. So, can I have them? I just want an OBJ of this. Save. What will it save? No, don't. I don't want a picture of it. Explode. Ooh, that's nice. So, like, just let me have it. Why doesn't somebody just have these? Why doesn't Wikipedia let me have an OBJ of every model? That's so much to ask. I don't want to. Somewhere that I have to log in or pay money. We get anti-prism, just generate some, I guess. But I'm sort of disappointed that there's just not like University of XYZ. It's just a long list of okay, well, we could try to install anti-prism. In fact, I think there's Windows downloads. Nope. The coolest, basically the coolest program to ever exist, roughly. I think it's roughly the coolest program ever made. So I think somebody made Windows by ignorance. Ignore the antivirus rule, okay? Bash on Windows, Anti-Prism PPA. Oh, is this stuff I'm using Windows Subsystem for Linux? I am, aren't I? Sudo apt get nope apt sudo add apt I don't know why I'm typing this. I didn't cut and paste it. Oh, that might mean that A view doesn't work though. Maybe I shouldn't have done this. So, do I have to do this and then install it? Like do that and then apt install? Yes. Oh, the instructions were right here in front of my face. In front of my face all along. Anti-Prism is the coolest software package. So we want just some cool shapes. Basically. I don't know what these. Like what? This guy? So we're just looking at small stellated dodecahedron. Well, we could do it with the edges. Okay, so can I run a view? I feel like it's not going to work. If I try to A view a small stellated dodecahedron. A view SMST DOD. What? No, anti-view. Oh, did I just install some dumb thing I didn't mean to install? Anti-view small ST DOD. Failed open display. Yeah. Okay, so we'll have to do like obj to off. No, off to obj for small st. Okay, here's what we actually want. OFFutil. Is that what it's called? You're killing me. Well, it's just geometry only. I think it's G. Okay. So we want off util dash G small st what? Small st dot. And then we want to send that to off to obj. And then we want to send that to I don't know if this actually will work right. Yeah, I can't do that. It's no. And this is sma sta dot obj. Okay, so we should have now generated this model. It's a roundabout way to do things, but now we have you know, some stradods. Where? That's you. Looks broken. Is it too tiny? No, it looks just not right. Should come with faces and points. It kind of looks like a thing. Vertex faces. OBJ. Yeah, what's wrong with you? No model. 0 vertices, 0 triangles. That's not a good model. Is there an error when I try to... A polygon default is self-intercept. Okay, so there... That's weird. Off to OBJ. Off util. Oh, is this because of the way it creates the model? There's just tons of crazy overlapping. That could be. Let's try it with just a snub dodecahedron. That'd be kind of lame. A snudod. Not totally surprising, but also not cool. Okay, yeah, so that exists. And then we want like no unnormals. Okay, we do want some normals. I don't want no, I don't want no, I want no smoothing. Okay. We have like a snubdodecahedron, for example. And then it's a prefab. I guess I could drop the original in here. Is that true? Might be tiny or weird. Wow, no, they're not tiny. I thought they were tiny, but they're huge. Now, are they too tiny? Our little cute snubdodecahedrons? Okay. So there are those. I wanted to use the stellated whatever. But I could make these models, but I just don't want to. Just not feeling it. Let's just crank out some shapes. Like a tet. Good old-fashioned tetrahedron and an octahedron. And a hexahedron. It's also cute. I mean, I don't need the cube. I have a cube. Cube's boring. An icosahedron. Everybody loves icosahedrons. Like, these shapes are cool, but, you know. Look at this thing. A tritet. Look at this thing. Pentagonal icosatetrahedron. We're just getting into nonsense here. Those are okay. These are all the these are all the uniform polyhedra. Wait, no, they're not. Common polyhedra. These are the uniform polyhedra. So, I think Unity just does not want to deal with all this intersecting madness. Because I think this is the way it makes it is this face is underneath here, maybe. I think it doesn't. Like, Antiprism doesn't care about tons of insane intersection. Unity's not into it. Okay, but does this work? What about a dual, like the UD18? I don't know if that's gonna work. Okay. You and then all these friends. Wait, is that all of them? Did I delete some of my friends? Got your Ico, we got your Oct, your Ted, your Snub. Who's missing? Oh, the one that didn't work. Yeah. Sure, you don't want that. It's broken. Do this. Let's use only our cool friends. Our scale is going to be off on most of them. Didn't fix that. 2.5. I don't know. Maybe this is the wrong path. I'm trying to make something cool today. That's so much to ask. Yeah, that one guy did not work. UD18, not. Not happy. Okay. You can go. You can not cast shadows. And do you sell too little now? I don't even know anymore. Okay, there's some very silly smoothing angles. So which one did we actually, this one is fine. And we did no smoothing source, yeah. No smoothing. Should be a little better. It's gonna have weird blobs. Maybe if the light shone straight forward. I might have put that the wrong direction. Okay. We had more variety. Oh yeah, we deleted something we were supposed to. This. I kind of feel like these would be cooler if they were cages. Our speeds are really don't seem pretty good. It's probably they're integers and they should be afloat. Integers, wish you were floats. Okay. So I could just do the edges. We could also do these weird Leonardo shapes. No, they're not weird. They're just Leonardo shapes. Rotations are just too uniform. I feel like we have a wide range in there, but probably not wide enough. Okay, how do we make these shapes better shapes? Let's not make them off-white. Let's have a material for them. Shape. How am I gonna do this? How many materials? Shape. 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 Did that actually change anything? Who can say? The tetrahedron feels a little small. Or snub dodecahedron, which I don't know if we want that. Maybe we just want straight up dodecahedron. We get fancy with this snub stuff. Oops. Oh, U.25. Make all these others 0.5 maybe. Perhaps the snubbing of it messes with the scale. It feels a little better. What's going on with these other shapes? They're just really boring because of the way they catch the light. Oh no! My network failed? Well, this is a crisis. What happened? This hasn't happened in a while. Did the internet just straight up go down? Straight up go down? Can't reach this page. Well, I've been streaming for 3.5 hours and I'm hungry. I really finish this tomorrow. It's a sign from the internet that I shouldn't stream anymore. Like, I feel like we're not too far away from something semi-interesting. Some of these shapes look terrible. I don't understand why. Oh, the octahedrons, when lit, just straight on. Huh. Yeah, we'd have to rotate them. Rotate all the little individual constituent. Constituent? Is that the word I want? Well, this thing didn't work. And I have no internet. So, can't reach this page. Okay, I'm gonna unplug the router and plug it back in, and maybe like do a little dance, loosen up a little bit, and then maybe we'll come back, or maybe I'll just come back to end the stream. We'll see. Okay, we'll see what happens. I forgot how stuff worked for a second. I had some snacks. I did that bad thing where I just was like a drive-by snacking, where I just like ate a bunch of snacks, and I don't know if they're gonna make me feel. I don't think it's a good idea. Where it's just like you just snack roulette, just grab the snacks you can. So the internet is back. OBS is going to reconnect in 90 seconds. It's great. Okay, so shapes. Wait, is this a weird tetrahedron? Why does this tetrahedron look like a cool kite? I want these though. Look at these. Why can't I do it? So there is another program though. By the way, BT dubs. It might not look good lit. I mean, there's a bunch of programs and all cool. Zone, I don't even know what a zonahedron is, but I think I need to learn. What are you, zonahedra? 45 seconds. It's very exciting. Okay, so there's this thing. I don't know if the edges have thickness, is the thing about them. Kind of looks like they do. Like, this doesn't really look like it has thickness, does it? That wooden one did. Flat. Using 0 for the height. So height, that's a lot of width. Does height mean there's some thickness? Oh my gosh, are we back? Welcome back, me. Hide edges that run from the outside faces to the holes of these. Why would you do that? I wish these pictures were a little bigger so I could tell a little more what's going on. Because these look like, are they just... I'm just gonna make one. Just try it. Okay, let's try this. I messed up. Close bash. So it's off util. Oh yeah, we got it. Okay. It's this. No, we want to send Leonardo to off to OBJ, not off util. How come this one doesn't have an adorable short name like many of the others? Leonardo. That piped to that. Okay, I don't know if I'm gonna like this or not, but I kind of just want to make this happen, get on with my life. Calculate the normals. It's kind of hard to tell though. Is there thickness? There is thickness. Okay, there's thickness, and that looks, I'm into it. End of the thickness. So, do we think this is like 0.25? Because we don't know. We'll just guess, and we'll apply. And then we will say, we really do need to make these individual things rotate though. I feel like that's more than cool shapes. Cool shapes are important, and everybody loves cool shapes. But I think that the bigger issue is that these elements are static. We could also randomize their scale. That would help these places where there's just like two duplicates one after another. Okay, these things are it's too big. I mean, would it be cool if they were all cages? Would it be cool if they were all made of gold? Can make these very metallic. And very smooth. And golden. Thing about gold, said it before, gold is not a color. Like, gold, the color gold is not what makes something look pretty. It's the environment that it's reflecting is what makes gold look nice. Like, really want gold to be just kind of like muddy and very metallic. And then you want it to reflect something cool, but we don't have anything cool to reflect right now. So maybe they're not gold, maybe they're just metal. Maybe they're black. Very black. Not metallic, but very shiny. Maybe they're not quite black. I mean, you could almost see if they were all the wireframes, though, that they could all be flat. But you can only get away with that if they're all going to be the wireframe guy, and also the wireframe guy doesn't have the material. Which one was that? That was this. Like if all of our shapes were wireframes. So if we just did the exact same thing, but laid a Leonardo of Tet, for example, and Oct, they might be too thick. Like the sort of border parts might be too thick. Definitely cooler. Okay, we can cut this other guy because this was just. No, we want a dodecahedron, but not a snub, right? We just want a regular dodecahedron, a dod. And we can have a cube too. And we didn't do an icosahedron. Okay, yeah, bunch of nice platonic solids here. Show you. Except for the weird thing, the rhombic thing, but we'll ignore that. Okay, so now can we do one of our stellated friends if we're going to do Leonardo? No. Where am I? Like what happens if I do one of these weirdos? Asmustadad. I'm just duplicating the same command over here, by the way. Whoa. Like, does that make something reasonable? It's not unreasonable. Not exactly what I wanted, but it's just got all that noise inside that I would prefer it did not have. So I kind of think it's not going to look great because of that noise. You might say it would look noisy. I guess is kind of the word I'm looking for. These huge cubes. This cube's so huge. Cool it, cubes. We could definitely make these more wireframey. Oh no. You need... Is that you? It's you. No, who is... It's you, it's Dodd. Okay. The star guys are cool shapes, but they... No, really they're not working super well. The tetrahedrons end up really weird. Just the way they get skewed. A Plague Tale Innocence is on sale. How about that? How on sale? 66% off. That's pretty on sale. Do I actually want that game though? I don't know if I want it. Seemed interesting. Okay, so man, we've strayed so far from where we started here. Does that thing still work if we just did this and did buildings and regenerate? Yes, it would still work. And it would look kind of cool. Man, I like that. How come... How do we get this? We don't scale as much. We don't move forward as much. We don't move forward at all. I mean, this would be very little forward. Okay. I want this. More like this. So let's... I know, it's funny because we... being fickle. We want to... Position speed to be way lower. Like, almost nothing. And if we do this, they're just gonna... Scale is gonna go nuts. Right? They're just gonna squish on top of each other. And it's okay though. Is there any randomness on the scale? It just goes, right? I still think I want way less of this. And then scale is U. I don't know. That's probably way too... That's probably wrong. Hello, very tiny friend. Okay, that was too little scale. Really should expose these so I can do them a runtime, but who knows what I'm doing or why. I mean, do we just get rid of the forward position? Is that our whole problem here? And then just find the right rate for the scale. Really understanding the overlapping. I mean, one or the other has to go, right? The scale or the position, or it's just too confusing. We can't get that other thing. That other thing is not available to us in this approach, because part of why it looks so good is the higher counts. That's what looks nice about that. That's the problem. Those stars are just so sparkly. Something's too tiny. What is that? Is it the cube? I made the cube too small. Sorry, cube. That's better. You're also too small. What are you? Another tetrahedron? You're too small. No, tet. Just be one. The stars are cool. They're just real dense. I'm not crazy about it. I don't know how to. I don't know how to deal with that. Probably a way. I mean, I kind of like it. I just don't know what to do about it. We have two different things going on here. Because the scaling up's never going to give us this. But the count changing means that it'd be way too dense in the smaller regions. They just kind of have to be sort of two very different looks. And I'm not sure. What to do about that. What do I do about it? Yeah, okay. So instead of scaling, one problem is the way we're scaling. We're scaling at like a uniform rate rather than a percentage of whatever our current scale is. That's why it looks like they slow down, because we're just adding progressively less and less. Okay, but they can't start at 0 if we do this. We've been so good at getting a study per stream. I just don't know. I feel like we're gonna get a study today. Wait, scale 0. Times a fraction plus equals. So to continually add a fraction of itself. And that way what it adds every frame will grow, yeah, like this. What? You can't zoom out. It grows forever. There's no escape. Kind of true. Okay, if we so that's not bad. Now if we just like a little smaller. It's just a little too fast. Still too fast. This will be too slow, but let's just start here. cubes are pretty boring. Really interesting how like the dominant rotation will take over. Cube doesn't have the right material, does it? I should probably, for now, even if I don't decide to in the end, make this a color, just so it's easier to tell when I screw up. Come on, little buddy, you can do it. Definitely don't like it when there's just two of the same thing right next to each other. There's ways to prevent that. Okay, what are we even doing? This is okay, we could have more shapes, we could have more animation to the individual pieces. I think animation on the individual pieces is what's going to give us the most bang for our buck, but that's also the one that's sort of the most annoying thing to do. Counts could go higher as well. And we really need to want like maybe 5 to 25. I don't think we really gain anything by being super sparse in this approach. Also don't really gain anything by starting this small. If it's too big, you'll see a pop, but I think it's okay. Okay, I don't like the pop. Never mind. Not that I would mind it, but I do. Yeah, also, there's no real reason on one ring we couldn't alternate prefabs. We have to make sure we always got an even number. Ideally. I kind of like that. I mean, I kind of just always want to do it. So to make sure we always have an even number, we just do like 4 12 and double it. Okay, so that's gonna do it. That's gonna do this. When it comes time to actually do this, oops. This might be too much. It's probably too much, but we're forging ahead here. We could do the same with, I'd have 3 prefabs and what do I think about this? You should still occasionally have rings of the same. Star Guide is so different. I don't like the pop, but I also don't like waiting for it. What are you gonna do? A little less tiny? Well, I can stare at it a lot, which is always a good sign. It's just pretty static. I mean, I don't know. What if I made 2 radial cloners? I don't like it. However, it does kind of make me think that we could do this. There's probably too much. But I think the real thing is to do the thing that I'm putting off, which is transform all of our friends. This was not the right choice. Okay, so how would we do that? We would want to say for our ring, in addition to having the ring object, we could always get the children from that. It's certainly a thing we could do. So like as we go through and animate the rings here, and this would be a game object. What do we call this? Orbit? What do we call this? Origin? Get child J. That was not very safe, but I feel confident that there's one child there. And then, like, we just did this same thing. It'd be kind of cool if they had a little bit of an offset, actually. Maybe? Maybe not. I don't know if I did that correctly. So that's them rotating. We want probably local rotation. Is there some other? And then let's do the right. It's a little weird because it's going to be like, you know, their rotation speed will be determined by the rotation speed of the whole nest, but something about it that's just like, I don't know, it's a little too Lucky Charms. You know what I mean? Like, there's still a quality of that. There's still something about that very first thing, the static version, that I like more than any of the animated versions we've done. It's a little better with that. This was just like a bunch of stuff. There's a lot of negative space. Maybe 4.8 is the wrong number. What do we do? 4.12. Fill in some of that void. Maybe get even a little denser. I mean, yeah, this effect would probably be better if it was just a spiral and it just spun around and individual objects had their own trajectory. Where do I get our rotation speed? Because I still don't like it. The counter rotation is pretty interesting because the bigger counter rotations are what kind of tell your brain the overall rotation, or the bigger rotation is what sort of guides your brain to decide it's rotating left or rotating right. And as it scales, that shifts. So yeah, my brain wants to bounce back and forth between thinking this is rotating left and thinking it's rotating right. What if we had another one of these? And it was a little further back. And its shapes were use a different material. Oops. I don't want our... Okay, first of all, do I like that? We could do something similar by changing the interval. Change the spawn interval. But I think those rotations here even faster. The rotations of the little constituent. I keep saying that. Is that the word I mean? 0.25 spawn interval. This is gonna be like on top of itself, but maybe that's what it needs. You know what would be cool, but I don't want to deal with it. Yeah, this is what would be cool. If you could have a, oh man, yeah, I like this. I think this is the way to get the best of both worlds. Is if you just had an increasing radius, you're not scaling up, you're increasing the radius. So these never grow larger, they just go out, right? But when they get to a point where it's too toothy, where there's too much of a gap in the middle, they spawn new elements to make up for it. Like if I have two that are moving like this, they're spreading out, spreading out, spreading out. Suddenly I start to scale one up in the middle. And then as all of those are scaling out, I scale another one in the middle. I think that finger gesture did not help make my point, but hopefully my words did. Like I would like to have some little study today, but I just don't know if I like this enough to... What if it was inverted? Yeah, so what oh man, should I just do it? We've been going a long time today. I kind of want to finish today and maybe do that tomorrow. Even though kind of none of this is exactly pertinent to my long-term residency goals. Would fog be cool? I don't know where fog even is anymore. Moon lighting? Fog. Oh, I can't do fog. There's no depth. You fake it with a radial gradient from the middle. Fog might be kind of cool. Are there missing back faces? Looks like something's weird going on with these. I think there are. Or the normals are bad, something. I had a weird shader that like fakes the fog just as you move away from zero. Kind of, let's just do it. Let's just do that. Oh, weird unlit shader. Making lots of choices today. I don't know if any of them have been good. Okay, so we have this. And we want to say something weird like We don't actually care about fog. I turn that off because we don't need it. What we want to do is basically say when we're close to the middle, is there a distance function, length, distance. So if we had like the we don't have the world position. How do we know that? Let's see, wait. The thing we've ended up doing a million times. Have we done it on a thing that's in this project? Where did we just do that? What the heck was I working on? Based on the world position. Gosh, what was I working on? Is it in this? The turbulence? Yeah. So we did stick it in normal. It's the singing guy. Okay. And then world position was equal to this. And V2F. Nope. In here. And then inside here we know about world position. What was I even doing? Oh, it's for that sphere. Okay, great. Now I remember. Okay. Whew. Okay, so if we have a distance between the world position and all right. We want like a magnitude. Like that's a basic stroke. Like a square magnitude. I don't know, man. Let's just do this. It doesn't have to be super formal. And then we'll just say for now, definitely broke that, but kind of accidentally like the color. What's wrong? Before. Why is that an invalid subscript? Because it doesn't go here, it goes in B2F. 59. Sure. So I'm a little confused here. Let's try. Oh, that was part of the problem. Don't return yet. Okay, so pretty weird, huh? But I guess that makes sense. Maybe. Oh, also call off. Oh, fix all my holes. Okay, that feels a little better. So what's my problem? Like if you're 0.25, you'd be mostly that. If you're 0.75, you'd be mostly that. So what is my problem? Is my world position not actually good? I've used before. My world position. If I said world position X, for example. Okay, so there's some gradation there. It's just huge. My camera be even further away? I should definitely make this a function, but hey. I mean, a parameter that can be passed, not a function. And it's kind of cool. Is the post-processing what is killing it so much, or is like we truly... Because we're straight up white. We have to go white all the way through. The fall-off is so silly though. Like there's not really... we're really getting much... We don't have much gradation here. I mean, we kind of want to say... Like, what's wrong with my logic here? Seems like the fall-off is crazy. I mean, maybe I want more like a range. I'm kind of into that. I guess we probably can get away with overlapping them if we get this fall off working somewhat well. I feel like my logic is wrong here somehow. Like, can I just square it? Is that why it just feels so dumb? I'm just changing numbers. I don't really understand what's going on anymore. Well, sure. I mean, that color should actually be the color of what the camera is. That's just true. Too many numbers. Well, that's more like, I mean, I don't like it, but it's more like what I meant. Yeah, if you had like God rays shining through these or something, that'd be way much cooler. Yeah, we've been fighting this one for a long time. Close to 5 hours streaming, just trying to make this look good. It's just one of those days that stuff doesn't look good. Okay, if we stop, we still should be good except for the camera change. Which was what? We probably want it a little brighter than I had it actually. Oh, like 757575. fawn rate was too high too, I think. I don't know. I'm not very pleased. You gotta wait a million years for something to happen. Because we just start our spawn size bigger, so we know it's hidden now. We're almost at the point where we're just gonna say, this is the thing. This is the thing we've made. Can't all be bangers, right? What's I don't know when it's safe. Is squaring wrong? I mean, is that just not the right idea? Where am I? That worse or better? I just think it kind of sucks. I think is my professional opinion. Because it's okay. It's just not very good. As a professional. That's my diagnosis. Just too uniform, you know, just a little too... I can't believe we spent this long making something so boring. Guess that's how it goes sometimes. I don't know what to do. Let's like, I think this process is called lipstick on a pig, when you just keep like, there's something that's not very good, but you just keep trying to like polish it up. Whoa. You know, it's just a bunch of shapes. I feel like maybe it's better when it's just this thing. This thing doesn't even work anymore. We destroyed this thing. How did we destroy this thing? Oh, they're just ghostly particles on a dark background, that's all. Remember this thing? I think this thing was better. I don't know what's happening now. The rules are all crazy now. Oh, it's our alternating path thing. Because this does allow for our alternating shape thing. Because this one allows for odd numbers. And that makes it crazy. So we did break this. Well, heck. I'm definitely ready to be done with this. I don't like it anymore. You can only put so much bloom on it. I mean, this view is kind of cool. No, he has some like world versus local position stuff though. Actually, I didn't mind that horribly. Something about where we... That was, maybe where we add the... This. Or here? I don't know exactly. We definitely have some world versus local space issues. Which, like, are kind of cool. Stuff disappears, I guess, just because it goes beyond the clipping plane. Not ideal. Guess we could invert our shader. And they would just fade away. Maybe? What the heck? I don't think I really understand what's going on. I mean, it's certainly a world versus... But even without this animating? Very weird, right? So it's something like position. You? No, because that's just in the building. It's not that. It would have to be in the, well, maybe this, actually. Yeah, I guess that's it. bloom is really something. Okay, they should never go to white. Why are they going to white? Oh, because we need to clamp? No, what is it? I think I've just never worked for so long on so little before. Yeah, that's the distance. And clamp it between 0 and 1. Oh, and then don't forget another parenthesis. Okay. I mean, I think it was cooler when it went out of control, right? Like that was... Is that the secret? Is just let it lose its mind? Like -60 on the camera. And then go back to being a little smaller in our spawner. Just a little. I mean, it's still gonna pop, but I think it's okay. It's not at all what we set out to do, but it's kind of cool. Like we're really quite far removed from our initial intention here. What we're getting is, that's pretty weird. But maybe I like it enough. Well, 45 since stuff right at your face. I don't know about 45. 2.5. Might be too boring. Maybe 30 was the magic number. I'm gonna say 36. I'm gonna say 36 is actually the magic number. Because, you know, spheres, degrees. $32 is the one. It's definitely 32. The magic number is 32. Study number 6? I don't even know anymore. Clumpy, and I don't like that. But I don't think I actually quite understand enough what's going on to be able to tune it in a very deliberate way. Camera too far away? No. We gotta just like get on with our lives at a certain point. Should have done it hours ago. This has been a lot of work for a thing that's just not that cool. Like, it's kind of cool, but maybe not that cool. Sometimes it has a lot of depth, and it seems pretty cool, and sometimes there's just not enough depth, and it's too clunky or clumpy. What happens if we do this? Whoa. I mean, so like, if I duplicate this and do the same thing on X, I get insane. Maybe with a longer spawn interval. That's a lot. Gonna reverse the fog. I don't think I want to do that actually, because the fog was our solution for clipping, but I just want to see it. That's better. What if one is 90, one is negative 90? Which is a mess. I mean, it's like, it's almost cool. But it's a lot. It's a whole lot. I don't know, man. What am I gonna do? Panic? If I didn't alternate the rotation, that seems to be what's causing the madness, what would it be like? Wait, what? Five and a half hours to just make nothing. I didn't randomize the rotations. It's just said 30. That's too fast. And kind of if you have no offset, you don't really get much of the .45's not good. I don't know, man. I mean, I haven't known for a long time, but I continue to not know. This is just my update, my hourly update on just how much I don't know. If we do this, we could switch back to the... Oh. I just think I don't like it. I continue to not like it. I like another idea that I have to scale up and then fill in negative spaces. But this thing I don't really like this thing. Very much. I just want to look at my... Let's just take a trip down memory lane. These things. These things are cool. Why didn't we just do this? Where did we go wrong? I mean, actually, what if we just turn this off for a minute? I just want to see. I just want to see. Oh yeah, we also shouldn't kill them. Okay, we need to not do this. What's happening? I hit the wrong button. Oh no. Well, interesting. Okay, that's no random rotation speed though. When do I give up? Pretty stubborn. But my stubbornness is wearing thin after 5.5 hours of just nonsense. That didn't seem right. Why? Rotation speed, random range. Maybe this is not actually a thing that matters the way I think it matters. I mean, all these things are almost, you know, they're like almost interesting. But none of them are actually good. And we don't get a study today. I'm not feeling very good about these. We explored, so that's fine. But I don't know that I feel like any... I mean, truthfully, all of the animation stuff is like nothing to do with our long-term goal. We wanted to explore generating radially symmetrical forms, and we did that like 4 hours ago. And they're fine. They're fine. They're just not good. That's it? We're throwing in the towel here? Five hours, 36 minutes. It's entirely too long to do a stream that you don't actually accomplish anything. But infinite tweaking is like, it's not great. What did I do? The whole goal actually was to, an hour ago, was to just find an interesting camera angle where we could look at it from some different perspective. Uh-oh. It's just a little frustrating because I feel like we've come close to something good a lot of times. Like we've been near-ish good for a while. But we just haven't hit it. I mean, this is good-ish. It's not good. Why does it sometimes look cool over here? Why? How? What's your secret, other window? Just your background color? Is it where you are? You can see. Like. I'm just not very into it. I'm just gonna call it. I'm just gonna call it. Discouraging. Oh well, that's how it goes sometimes, I think. You win some and you lose some, and a few get rained out. And I think we're just gonna call this one rained out. Oh, but look at this. Look at this little creature. My camera's in the way. See? Ah. Hello. Hello, little friend. Are you sleeping? Are you asleep? You want a kiss? Good night. Good night, little friend. Oh yeah, this is bad, because you can't nudge these with your keyboard? Is that true or false? You can. Okay. Now I'm tired and cranky. No, I don't know. It's not. I could just push at it forever and eventually just give up and put something out that I didn't like really much. But whatever. Let's move on. I don't like to give up. It's not giving up. We're living to fight another day. Live tonight another fate. No, live to fight another day. Okay. I'm getting delirious from streaming too long. I gotta go drink some water. Have a lovely day, and I will see you next time. Bye.